All right, so the title of this section is sinusoidal functions. Now, sinusoidal functions includes sine and cosine. Those are both considered to be sinusoidal functions. I think a more appropriate title for this section would be horizontal transformations. So in 9.4, we focused on vertical transformations, right? Stretches and compressions, and also vertical translations up and down. In this section, we're going to deal with the horizontal transformations. So a horizontal stretch or compression, or we can also get horizontal translations. All right, so we're going to start with a stretch or compression, which a stretch or compression of the sine function is going to change the period. Okay, it's going to change the period. So it's going to change how long it takes for to complete one cycle. All right, now I think that the horizontal transformations are a little more confusing because they seem a little counterintuitive when you first encounter them. But because if you have, so let's just take a look at what I've got here. So the horizontal compression. So basically what I've got is f of 2x. Now you might have done transformations in 108. I think you did. And you learned that this is a compression. And the reason for that is that I'm basically taking the input x, I'm amplifying it by 2, so I'm doubling it, right? And then feeding that into f of x, okay? So because I've got this amplification going on, I'm multiplying it by 2, right? I'm taking x and multiplying it by 2, then it only takes half of the amount of x to get the same output, okay? So rather than cycling between 0 and 2 pi, let's take a look at what happens to the period. So our input to the sine function is 2 theta, right? So I'm going to actually draw a little graph. I'm going to have a column for sine of 2 theta. Okay, so this is our input to the sine function, right? Is 2 theta. That's our input. Now, when I put in 0 to sine, I get 0, right? When I put in 2 pi, that's one cycle, I get 0. All right. But so this is our input, right? So but I want to know, what are the values of theta that correspond to that? So again, when 2 theta is 0, theta has to be 0, right? So this is 0. But think about what theta has to be in order for 2 theta to be 2 pi, right? Then theta only has to be pi. So rather than cycling, so sine of 2 theta, rather than cycling between 0 and 2 pi, it's going to cycle every pi. So the period becomes pi units long. So here I've graphed a couple of both of these functions, the sine of theta and the sine of 2 theta. Okay, and you can see, where the original function, the original function, one cycle went from 0 to 2 pi, so there's one cycle. I've kind of highlighted there. Well, try to highlight. I should probably use a highlighter. So there's one cycle. Now, sine of 2 theta cycles over pi radians. Okay, so the period is half of what it was. Okay, so the sine of 2 theta has a period of pi, half of the normal cycle. Okay, so let's put that information down here. So normally the sine theta midline is 0. Here the midline is still 0. Okay, amplitude is 1. Amplitude is still 1. And the period, though, now before where it was 2 pi, now we only remember it takes half the input to achieve the same output, so it's going to cycle over pi radians instead of 2 pi radians. Okay. All right. So let's take a look at this first example. Just kind of an extension of what we just did here. All right. So I want to know what's the period of y equals sine of 3 theta. All right. So again, the input to sine is 3 theta. Okay, think of that as the input to sine. And so this is sine of 3 theta. So I know when the input to sine is 0, I get 0. When the input to sine is 2 pi, I get 0 again. Okay, that's one cycle. Okay, so let's see what amount of theta it takes, right? So when theta is 0, 3 theta is also 0. Okay, but if I need 3 theta to be 2 pi, right, then theta only has to be 2 pi over 3. Okay, right? So when theta is 2 pi over 3, I multiply times 3, and then 3 theta is 2 pi, and that is my input, right? That's my input to the sine function, is the 3 theta. Okay, so it takes now a third as much theta to achieve the same output. So now, rather than cycling between 0 and 2 pi, we're going to cycle between 0 and one cycle is going to go from 0 to 2 pi over 3. So we have a period of 2 pi over 3. Okay, so 3 times the theta gives you a third of the period. Okay, so and we could sketch that if you wanted to. It's just going to be, it's going to go from, and again, so this is one where, okay, the period is going to be 2 pi over 3. Okay, so then right in the middle is pi over 3, half of that. Okay, and then half of that again is going to be pi over 6, and then half between pi over 3 and 2 pi over 3 is going to be the average of that. So that's 3 pi over 3, so it's pi over 2. Pi over 2. All right, so our if we wanted to sketch that, it's still going to go from 1 to minus 1, okay, because there's no amplitude, there's no a value, right? We learned about there's no a value there, it's just an a of 1. And it's going to look just like the sine function is just going to go like this, right? So we're going to have a sine function that looks like this. And this is theta. Okay, I guess I didn't really ask for the graph. But the period is 2 pi over 3, a third, because we have 3 theta. All right, I will meet you in the next video and we'll talk about horizontal stretches.